Welcome back to Up in the Air for the beginning of Season 2. I'm Dakota Smith.
And I'm Meredith Fish.
Meredith is new to us this year, and we're so glad to have you joining us this year.
Thank you. I'm so happy to be here.
Meredith, tell us a little more about yourself.
I'm a junior here in the department. I'm in the option of weather risk, and I'm super excited for this upcoming season.
Me too. And for those of you that don't remember, I am a senior in meteorology with an environmental option. We also have one other person helping us out this year, and that is Ryan Brenton. Ryan Brenton's over at our climate wall. Ryan, tell us a little more about yourself.
Thank you, Dakota and Meredith. I'm a sophomore in the forecasting and communications option here in meteorology, and I look forward to being here with you this season as well. This week I'm in the climate outlook role, but each week we will shift roles here on Up in the Air. So Meredith will be here one week, Dakota the next, and then we will switch roles at the desk as well. So I look forward to a great season with you here as well, and I'll see you a little bit later on in the show with a look at the extended outlook. Dakota and Meredith.
Thanks, Ryan. We'll catch you later with the climate outlook.
This year we have an action-packed lineup that we will bring to you weekly. Students from our climate dynamics class will bring a segment that will describe a climate phenomenon in our Earth's atmosphere.
And then we'll have a climate outlook, which is an 8 to 14-day projection, emphasizing trends and anomalies all across our nation.
And starting next week, the Weather Risk Management Club here at Penn State will join us for a weather risk report.
Then finally, we'll have a Meteor Minute produced by our own Penn State students in the TV production class here, spanning an array of current weather topics.
So we think it's going to be a really awesome year. We hope you can join us every week. But now, here's Update in the Air.
While Pennsylvania is dealing with a shortage of rain for crops, surrounding states are getting too much rain at the wrong time. Pumpkin farmers in Delaware are not pleased with their pumpkin supply, claiming that too much rain early in the growing season for this winter squash has damaged their yield. This low supply of locally grown pumpkins has raised the price of a bin of pumpkins from a typical price of $110 to approximately $150 a bin, giving you 40 pumpkins for $3.75 a piece. The large amounts of rain have also delayed planting for broccoli, cauliflower, and kale. Luckily, that means that there are still plenty of fresh winter vegetables at your local farmers markets.
Recent studies have found that the Greenland Sea is warming nearly 10 times faster than the average rate across Earth's oceans. The study has documented water temperatures and salinity measurements for the Greenland Sea for over 60 years. In the past, cold surface water would sink during the spring and summer months, cooling the deep sea water. This process has not occurred in the past 30 years, while relatively warm water continues to flow in from the Arctic Ocean. As a result, the temperature of deep sea water contained in the Greenland Sea has increased by 0.5 degree Fahrenheit. Potential consequences of this warming is increased snow and ice melt in surrounding areas. As climate change continues to be at the center of scientific debate, researchers will continue to monitor the Greenland Sea.
With a strong cold front and associated rain band, much of the Midwest and Northeast were graced with much-needed rain this past weekend. However, due to the current government shutdown, accurate measurements of rain and their impacts on crops were not produced. The U.S. Department of Agriculture's National Agriculture Statistics Service is responsible for collecting the data and sending weekly reports of crop conditions and rainfall totals. However, this shutdown is affecting more than just weather reports. Many farmers rely on the government to track various crop and overseas markets to make decisions on prices. Although consumers have yet to notice an impact, a potential rise in dairy products is possible if things aren't settled soon.
Last spring, numerous forecasts were produced for the current hurricane season. Every forecast predicted too many named storms and too many hurricanes. Although there is still some time, most meteorologists agree the preseason forecasts will come up short. The lack of tropical activity can be linked to a large high-pressure system called the Azores High. The Azores High had a dominant presence in the Atlantic and created a conveyor belt of dry air from Africa to the Atlantic Ocean. Tropical systems thrive on warm, moist air, which was unavailable to storms for most of the hurricane season. Although the hurricane season is winding down, we should still be reminded that strong systems can still impact the United States late in the season. Last year, Hurricane Sandy formed near the end of October, devastating the East Coast. We'll be back in a moment with more.
Welcome back to Up in the Air. We now have students from our Climate Dynamics course here with details on the general circulation and how it impacts everyday weather.
The Hadley circulation, a thermally driven circulation. What do I mean by a thermally driven circulation? Well, at the equator, the Earth receives more radiation than it does at the poles. This creates an energy imbalance, giving rise to temperature and pressure gradients. The Earth, much like a living organism trying to maintain homeostasis or equilibrium, tries to eliminate these temperature and pressure gradients. One way it does this is via a circulation known as the Hadley cell. The image you see now is a depiction of what the Hadley cell would look like if the Earth had no rotation and therefore no Coriolis force. Where it is warm at the equator, the air rises to the tropopause and then is forced poleward primarily by pressure gradients. Without the presence of the Coriolis force, which acts to turn the poleward moving air circulation to the right in the northern hemisphere, the air would make it all the way to the poles, where it would eventually become cooler and denser than its environment and sink back down to the surface. As the air descends, it warms until it reaches the surface, where it is then forced equatorward by pressure gradients once again. With the existence of the Coriolis force, which arises due to the Earth's rotation, the Hadley circulation only really makes it to about 30 degrees north and south of the equator. Then, another non-thermally driven circulation known as the Ferrel cell, first theorized by Pennsylvanian William Ferrel, takes over. This whole process is repeated continuously because the Earth is always trying to balance its energy budget. Now, I will turn things over to Steve, who's going to talk to you a bit about the impact of the Hadley cell on our climate and weather.
Thanks, Brandon. So now that you know how the Hadley cell forms, you're probably wondering how this affects your daily life. Because the air rises at the equator and sinks near 30 degrees north and south latitude, the resulting bands of low and high pressure work to create some pretty distinct weather phenomena. At the equator, the moist, rising air condenses and produces thunderstorms in a process called convection. This forms a global band of high precipitation thunderstorms called the Intertropical Convergence Zone and can easily be seen on most satellite images. At 30 degrees north and south, the sinking of air creates a band of high pressure which acts to prohibit precipitation formation at these latitudes. This process is also why many of the world's deserts are found at these latitudes. As the air near the tropopause diverges away from the equator, the Earth's Coriolis force acts to steer the poleward moving air to the east, thus creating the subtropical jet stream. Conversely, at the surface, air moving back toward the equator is steered by the Coriolis force to the west, creating a feature known as the trade winds. This phenomena has been used by sailors for centuries to quickly reach the Americas and travel the Pacific Ocean. These winds also help to drive tropical storms across the world's oceans. Now that we know the Hadley cell's effects on our planet, Dan will explain how similar phenomena can be found elsewhere in our solar system.
Thanks, Steve. Do you remember what Earth's Hadley circulation would look like without the Coriolis force from Earth's rotation? As Brandon told you, we would get one giant Hadley cell in each hemisphere. That's actually what we see on both Venus and Saturn's moon, Titan. Like Earth, both Venus and Titan have solid surfaces and thick atmospheres, which means we can get Hadley circulation on each body. A day on Venus takes 243 Earth days, which is even longer than a Venusian year. Titan, on the other hand, is tidally locked to Saturn, just like Earth's moon, so its 16-day orbit is the same length as its day. Because of this slow rotation, Venus and Titan both have a single Hadley cell per hemisphere that extends from the equator to about 60 degrees north and south latitude. Beyond 60 degrees, where the Hadley cells descend, both Titan's and Venus's atmospheres become turbulent, giving rise to polar vortices as seen in this image of Titan. For Up in the Air, I'm Dan.
I'm Steve.
And I'm Brandon. We hope you've enjoyed our segment.
Welcome back, and standing by with us now, we have Ryan Breton with the Climate Outlook. Ryan, take it away.
Thanks, Dakota. It certainly has been a dry stretch of weather around much of central Pennsylvania for the past several weeks. We certainly had some rain, much needed rain last weekend, but still much of central and eastern, northeastern Pennsylvania is running abnormally dry according to the latest drought monitor. Also, same situation through the northern plateau up toward Bradford and the lake shore of Erie as well. We can certainly use some rain, and looking at State College rainfall since September 1st, which is the beginning of meteorological fall, this brown line is the average precipitation, the green line observed precipitation, and you can see we are running quite a deficit, somewhere around 1.5 inches of rain here in State College since the beginning of fall. So we can certainly use the rain. And in terms of our 8 to 14 day outlook, we do have some changes in the weather pattern here in Pennsylvania over the next couple of weeks. In terms of temperatures, no major changes. We are continuing to expect above normal temperatures on the eastern seaboard, much above normal temperatures in New England and along the Gulf Coast. No major changes in the western part of the nation either. Of course, you saw earlier in the show that picture from Wisconsin where they were dealing with, in Wyoming rather, where they were dealing with the snow. We're expecting below normal temperatures to continue through the western and southwestern part of the nation over the next 14 days. In terms of precipitation, a large swath of above normal precipitation is expected all the way from Texas through the northeast and mid-Atlantic, so that's some good news for our rainfall deficits here in Pennsylvania. In terms of below normal precipitation, we're expecting that down in Florida and also through the northwestern part of the nation and up into Washington State and Oregon as well. That's the climate outlook for now. We'll be back in a moment with more from our communication students in this Meteorology Minute.
When people think of an earthquake, a hazy Southern California skyline often comes to mind. According to the U.S. Geological Survey, 26 urban areas in the U.S. are at risk for significant earthquakes. Only 3 are on the East Coast, but sizable quakes do strike this part of the country.
It was downright jolting at the epicenter, a one-stoplight town in Virginia, and it spread out from there. In fact, look at this. This quake was felt in 22 different states.
And if August 2011 taught us anything, Easterners need to be better prepared for an earthquake. According to EarthGauge.net, there are several actions you should take in the event that an earthquake hits. If you are indoors, don't exit the building. Falling debris may cause serious injury. Instead, lay down on the ground in the middle of the room. On the other hand, if you are outside when the quake hits, find a safe location away from buildings, trees, utility lines, and any other object that could fall, and lay down.
So the next time an earthquake surprises us, make the safe choice and proceed with EarthGauge's tips in mind. For Up in the Air, I'm Tyler Jankowski.
Well, that about does it for us here at Up in the Air. Next week, we're looking forward to the Weather Risk Management Club joining us with our Weather Risk Report.
Well, Dakota, I think we've had a great start to the season today. And make sure to catch us next Thursday at 7 o'clock on CNET Channel 7.
For Up in the Air, I'm Dakota Smith.
And I'm Meredith Fish.
See you next week.